Hello, everyone. Thank you for joining us for yet another episode of the Amazing Podcast, where we talk about all things cloud native, Kubernetes, DevOps. And I'm excited to bring you various kinds of guests on the show, from large enterprises to startups to people working on open source and even the CNCF. And I'm Twain Taylor, editor at Amazing. And if you like what you listen here, what you hear here, definitely go and check out what we do on our website, amazic.com. That is amazic.com. We do a lot of cool stuff like we cover events like KubeCon and Hashi Days and a bunch of other different big conferences in the space. And we have blog posts coming out every day almost. And we have job listings. So there's a whole lot happening there. So go and check out amazic.com. I have with me today a startup that is working on something really interesting, something that a lot of people, you know, probably haven't thought too much about, but is very critical in how applications work. We're going to be talking to a startup working in the space of event processing for distributed applications. They work on a message broker, so this is just a term now, but we're going to break it down for you in just a bit. And we're going to be talking today to Yaniv Benhimo, who is the co-founder and CEO at Memphis.dev. And it's great to have you with us, Yaniv. How are you doing today?
Thank you. Happy to be here. Awesome. Great week.
Great.
Starting a new week. And yeah, everything is great.
Yeah, looking forward to the conversation with you because, event streaming and, message brokers can be quite a technical topic. And we're really looking forward to have you explain it to us in simple terms and get us interested in the details of event processing. But before we get to talk about, event streaming and all of that, if you could tell us a bit about yourself, your background and what you've done, what led you to Memphis. We'd love to hear that story.
Of course. So I've been a developer since basically all my life. I discovered it since I was 10 years old. I discovered programming and software and computers in general. So this is my life passion, technology in general. And then it brought me to different positions, bachelor degree in software engineering, all to EMC and Dell Technologies, where I worked for in the past couple of years. And during my time there, I've been in different positions related to data. So it started from data engineer and data architect and a consultant. So I got the chance to work with data from multiple aspects, from the engineering side onto building massive data platforms, all the way to the insights, extractions, and the scientific part of the data itself, which brought me to take it to the next level and try to understand how I can create a meaningful solution or a technology within the data engineering domain. And in the past 2 years, I've been working on Memphis Dev alongside my other 3 co-founders, which we met again during our bachelor degree. And yeah, we all share the same love for data and data engineering and engineering in general. So it was really natural to choose the engineering aspect of data.
I'm quite fascinated how a lot of the startups from Israel that we posted, they have a very similar story of, they met their co-founder back in university or in the IDF or a checkpoint. And then years later, they got together and they've built a startup. Really cool. And why the name Memphis? Does it have anything to do with the city?
Well, no, we just thought that we want to put more lights and look a bit different in terms of branding as our other alternatives, or in general, the data industry, which sometimes get caught in, I would say, grayish colors, something like that. So we wanted to put more light and more colors into somehow hard or challenging domain.
Yeah, it is quite a good-looking website. I see a lot of use of colors, purple, yellow, teal. It's really cool design there.
Thanks.
Um, so let's first talk about the key terms and definitions, right? If you can define for us what is a message broker, what is event streaming, what kind of applications are they used in? I'd love to hear that.
Yeah, sure. So message broker is sort of an evolution of messaging queue. So the most common terminology would probably for developers, and the common or the average developer would be a messaging queue. And message broker, which by the way, both message brokers and messaging queues offer a bit of the same these days. But when they started, basically the original or the source of message brokers was messaging queues. And messaging queues is all about creating a buffer between, I mean, in the simple form and how it started, it was all about creating a buffer between two components, two software components. So instead of one component to requires to wait for getting an acknowledging or response from the other side, it's just through a message, through some piece of communication, through an event to somewhere to the space, if you can call that in that way, and the other side will receive that message when it is available. So we really, the ecosystem invented that component to create sort of decoupling or buffer between different components, and then it grew and evolved over the years. And then we discovered that we need more types of patterns and more types of paradigms within that buffer. So, for example, if we started from one-to-one, one producer of a message, one piece of software that push messages to the other side, and you have only one consumer on the other end that received that message, we grew to patterns of many to many consumers and producers and consumers, that enables you a whole bunch of new use cases that were not able in the traditional messaging queue. So message broker is all about what you have in messaging queues, usually in the traditional messaging queues, but in a more robust way. So it offers a pattern, again, as I explained, of many to many communications. So you have multiple producers and you have multiple consumers on the other side. And from being a buffer between two software components, we grew to data lakes, to event-driven architecture to support massive ingestions of data from different SDKs and different types of platforms and different types of software. It enables these days the use cases that message brokers and event streaming platforms enables. You can find Uber that notifies the users or the customers where the taxi is right now. You can find airplane locations. You can find stock exchanges that constantly refresh their dashboards with fresh ingested data and real-time events. You can find connecting systems. So, for example, if a sale occurred and you want to notify both your BI and maybe CRM and maybe the real-time dashboard of the executive team, so you would use a message broker in the middle that gets all the sales events and then produce it to the different consumers, to the different systems. So it's a very powerful component. And these days, or in the context of developers and dev tools, it's also a very mission critical one, because in most platforms these days, because of the massive amount of data and real-time requirements and asynchronous requirements, usually if your message broker, event streaming platform, messaging queue, those are the same, like different terminology for the same component. And basically, if that is down or severing some outage, then your platform is probably down or not serving your customers as it should. So it's a very tier one mission critical component, yet a very robust one that serves so many use cases and different use cases for different domains and requirements.
All right, all right. Could you give us an example from simple like daily life to illustrate how this process works when streaming? Any example from real life that we can understand?
Of course, of course. So let's take, for example, DoorDash. If you and the audience familiar with DoorDash, DoorDash is it's a company, it's a platform that enables you to order food, right, from different restaurants through an application. So basically, the entire thing happens asynchronously. What does it mean? It means that when you reach out to the application itself and order something, then an event of ordering gets created. That means you are the producer of a message or event and you created an order. But we all know that on the other side, some human being will process that order and gets your food delivered to your house. So that entire flow is basically happens asynchronously. So what happens is that if your ordering action will trigger an event that will be produced into some message broker, stay there until some consumer, or in DoorDash case, maybe a delivery person, will consume that event, process your ordering, and then deliver it to your house. Now, it can take 1 second, it can take 10 minutes, but it's not your concern. You continue to do whatever you want to do, and that thing happens in the background. So I think that explains the asynchronous methodology or event-driven architecture perfectly.
Yeah, that's a great example. You probably explained this, but I kind of missed it. Could you briefly tell us again what's the key difference between a message queue and a message broker?
Yeah. So again, as I explained in the beginning, the origin of that type of component started from messaging queues. So messaging queues and message brokers are perfectly the same, but with one minor change is that messaging queues usually messaging queues usually will offer the pattern of one producer and one consumer. Now, it's perfectly okay, and you can do the same with a message broker, but it's not scalable. So if, for example, you want the same message to notify multiple systems or to be served to multiple consumers, that task would not be able to get implemented on a messaging queue. You need something more robust, or you need something that is able to support even not many to many, but at least one to many, one producer to many consumer pattern. And that pattern can be achieved using message brokers. Now, these days, technically speaking, messaging queues evolved, and now they created sort of a version or features within them to enable that type of a pattern. So the borders got a bit blurry between the technologies, but again, usually it would be the pattern and the scalability. So in terms of scale, you should not expect massive scale support by messaging queues. And if you're working with massive workloads, high throughputs, high amount of events per second, large message sizes, that means that you probably need a message broker.
All right, that's great. Could you give us some examples of the prominent tools that are being used for this task? What are some of the most popular message brokers in use out there that probably most of our listeners are familiar with or use day to day?
Sure. So the most popular ones started from the open source. The first one was RabbitMQ, actually, that started all the way back in 2007. And from RabbitMQ challenges, again, the pattern, the scale, the throughput, the robustness brought the market, brought the industry to build an alternative, which named Apache Kafka, so Kafka, but it's well known by its prefix of Apache and the association to Apache Foundation. So I would say queues would probably be the second name for queues would probably be RabbitMQ, and the second name for bulkers would probably be Kafka.
Yeah. Kafka is really widely used, really popular.
Yes.
And you mentioned a few key words in some of your responses that I caught, and I was wanting to dig a bit more into those words. Some of the words you mentioned related to time, because I think time is a very essential component to event streaming. And you mentioned words like buffer, real time, and asynchronous. And I think all these are related to time, how these message brokers handle the time component of these events. Could you talk a bit about that? Uh, how does someone look at these message brokers in terms of time, what they can do, and how they handle time differently? Maybe different types of tools that handle time differently. Or another way to put it would be, could you tell us a bit more about buffering, what that means, and what does real time and asynchronous mean?
Right. So in the very basic shape, asynchronous means that try to speak with Twain, for example, and I'm not necessarily wait for his reply. So it can happen now, it can happen in 10 years from now, but I did my part and send some message or try to communicate with him. And when Twain will be available, he will reply back. So that means asynchronously. I'm not waiting for a response. That's the first thing. In terms of buffering, now in terms of timing and buffering, if I understood correctly the question, so I would say you have two types of usability or usage around buffering. So buffer can be a push based or buffer can be a pull based. That means that you have a producer, you push the message into the buffer. A buffer is sort of a pipeline, sort of like an actual queue. Like that's the scientific structure, right? You push a message and then it gets ordered in a FIFO manner, so first in, first out. And each message afterwards will come afterwards, after that initial message. And then you get the pull based on or the push based paradigm. So basically, the other side will either pull events on their availability, or the buffer will push the events towards the other side all by itself. Now, it has some effect, some effect of about timing. For example, if you will do the push, then that means that immediately when a message gets in, it will be pushed on the other side. But it also means that that some back pressure will be created on the other side. That means that if, for example, Twain is currently not available to answer my call, he would still receive my call, but is not answering right now. So, but he's not available right now to answer or to get that call, and that will create some work for the developers that creates the other side, that creates the consumers, to make sure they handle that request. And probably, and that's the funniest thing, they will probably use a secondary buffer to put or to offload the messages that they are not able to consume at the moment. But it's a push based, so they have to receive that message. So in terms of timing, that would be probably it.
Okay, interesting. Yeah, I want to move to talking about some of the challenges when it comes to implementing message brokers and managing event streaming. What do you see as some of the main challenges that people face when working with message brokers?
Yeah, so message brokers, it's an interesting thing. Message brokers, I always think about it as, first of all, as a storage system. It's a temporary storage system, but it's sort of a storage system. It can also looks like a database, so you can also utilize message broker as a temporal database. It has most of the characteristics of a storage system and a database, and as other databases and message brokers, there are the aspects of the operation side. So the DevOps, the SREs, the platform engineers that needs to make that thing works and alive. And you have the developers that actually utilize their services or the message broker services into their application, into their use case. So if we're concentrating or focusing on the challenges of the developers, because the platform engineers and the DevOps and the infrastructure people have so many challenges of their own. But let's say that we are using a message broker or event streaming platform, a managed one. So most of the heavy lifting in terms of operations is offloaded by the operations team. So if we're concentrating on the developers, then usually they will face bad observability. So it's really hard to understand what's going on, who's speaking with who, or what's speaking with what, how the messages looks like, in which format, in which sizes. It's usually important to understand what is going to received by the consumers in order to code or develop the other side in a way that they understand how to interpret the messages that are receiving. Also application level troubleshooting. So these days, if we evolve from being a simple buffer and just integrate asynchronous communication or implement asynchronous communication between services, these days you can also see an entire pipeline or entire flow or chain of reactions based on, or sorry, around the message broker itself. So for example, you have a single service that produce data and then another service that consume the data, does something to it, and then re-push it to the message broker again, and then some other service, and it goes on. So it's really hard to understand what went wrong during the flow, during the asynchronous flow, all the way to the last consumer that consumed the data and expects to have it in a certain shape. So application level troubleshooting is really hard. Also, there are the mechanisms that developers themselves requires to build. So if, for example, you're working with push-based paradigm, that means that you need to create some back pressure mechanism that protects your application from burstiness and overload your resources with messages that you cannot process right now. Also retry mechanism. So if, for example, I simply crashed during processing of the event and I want to get the same message again, because it's important for me to not lose even a single message. It can be a sale, it can be some ordering, some shipping event, and I don't want to miss that and let my customer wait for their shipping for ages just because I dropped the message, right? So it's a very critical to make sure you are covered for that. Also, you have offset recording. That means that you need to understand. Usually, I mean, in the message broker market, that would be the usual challenges that the developers requires to work with, and a lot of repetitive code. So imagine that you are working in a branched organization and you have a team in Hong Kong and team in India and team in New York and team in Israel. And each one of them is working on their service, right? But you have a single organizational streaming platform that serves all of the teams. Now, just imagine how much repetitive code and how hard it is to collaborate and share the business logic of the different services between the different teams, which these days it's highly required to be more efficient and to reuse existing code and not to work on the same services across the different teams. So I would say all of those challenges are usually would be the top five when you're working with a message broker, or in general event streaming architecture, or asynchronous workloads.
Yeah, that's a great list. And I'm sure that a lot of people working with message brokers probably relate to those issues that you just described. I want to also ask about serverless. Serverless has been gaining momentum over the past few years? And what role does message broker play in a serverless application? Does it become even more important for serverless than a usual cloud application?
Yeah, definitely, 100%. So AWS CTO started his deck or keynote in the last reInvent, AWS reInvent in Vegas, with the phrase, the world is asynchronous. That means the world is filled with events and reactions to those events, right? And that is, I would say, a very direct connection to the serverless and why they invented in the first place. So yes, it is by nature connected to serverless and event-driven architecture. And I think that even in particular in message brokers, that as a finite time for storing data, it's quite like serverless, right? Serverless functions that live for specific task and for specific time. So I think that there is a very close connection between event processing and event streaming and serverless architecture. I think they invented to support those types of architecture, and we will see more and more of that gets built and gets implemented. But also, I think there is a huge cost question or cost challenge that needs to still overcome and understand, because there is a very stiff curve when doing event processing or event streaming um, in terms of scale and amount of messages that are need to be processed. So you need to balance between the two, but definitely serverless and event processing goes hand in hand.
Yeah, wow, that is quite a quote. The world is asynchronous, and I think very relevant to our conversation today. Now, I want to ask about switching gears to talking about uh, what you're building at Memphis. So if you can tell us uh, what is Memphis? What does Memphis bring to the space of message brokers that wasn't there before Memphis? Why does Memphis exist? Tell us about it.
Yeah, for sure. So Memphis, first and foremost, frictionless, intelligent event streaming platform. A more simple terminology would probably be message broker or queue, a very intelligent message broker or a queue. But what we like to call it, or we like to call it the modern streaming stack, to really help developers to build event-driven, real-time applications fast and efficiently.
All right. Yeah, that's quite a simple and a catchy way to understand Memphis as well. I understand that you got a walkthrough for us to show us what Memphis looks like and what it's like to use Memphis. Could we see you show up? Could we see Memphis?
Yeah, of course. Can you see my screen?
Yep.
Awesome. So that would be the web console of Memphis. So when you first deploy Memphis or use Memphis Cloud, that would be the first or the opening screen. Memphis is cloud native by design, written in Go and run on any Kubernetes on any cloud, or you can definitely use the managed version of Memphis. By the way, we are open source next to our cloud. So again, we talked about the observability and the troubleshooting and the retry mechanism and the offset management and the business logic that we would like to offload to some other place than our code. So let's go through the challenges and see how it gets solved. How it gets solved in Memphis. So again, that's the first, or the dashboard of Memphis. If I'll reach out to station is, or let's start with the industry terminology for sort of like within the message broker itself, you would find topics. Usually when you're working with Kafka, it's called topics. When you're working with RabbitMQ, it's called queues. And within Memphis, it's called stations. Why is it a station? Because we don't consider a station as an empty project, as an empty object, but rather a very intelligent piece of component that not just store data, but also process it and enforce schemas and dead letter and retry mechanism, and everything happens within the station itself. So on the left, you can see all your producers. So if you are a developer and you want to understand who is speaking with who, or which piece of component speak with other, so you can see on the left all of your producers. Those with the green icon are the ones that are currently connected and producing data and messages into the station, into Memphis. And on the right, you can see the consumers. So basically, consumer groups, the pattern or the paradigm that it works is that every consumer group receives all of the station's messages. So when you're pushing a message, for example, that's like the newest message that's received into the station, each of those connected consumer groups will receive the same message at once. Those are the consumers and producer. For example, dead letter. Let's say that all of a sudden your consumer group decided to shut down, to crash, to break, to something, and was not able to acknowledge the message, meaning it was not able to say, I received the message and you can bring me the next one. So automatically, without the need for the developer to do it on their own, the station itself, or actually Memphis Broker, will flag that message and flag that message as a dead letter message, and will put it in a different queue, waiting for you to understand the issue, perhaps resend the message or drop it. So if, for example, I'll go to that message that was flagged by one of the consumers, I will understand who was the producer. I will understand who was the unacknowledged consumer group that was not able to consume that message. And then on the fly, without changing a single line of code, I would be able to resend the message if I fix the issue or something like that, or I just want to try and see if the message is now can be accepted. If not, I can just drop it, and that would be it for that simple message. On the upper,
Interesting. I have a question on that. Can
please.
you also set automated retries or policy or rules to say, drop certain kinds of messages? Anything on that front? Any rules or policies you can set?
Yes, we do. Yes, we do. So if I'll go to the administration, basically through the administration, I can configure certain policies that will automatically retransmit the messages that are located within the dead letter. Yes.
That's great. Yeah, you can continue. You're going to show us something else.
Yeah. So no, all good. So on the upper corner, we can see some metadata on the messages. On the station itself, we can see the amount of replicas. If we want more redundancy or less redundancy, we can choose disk or memory. So if we want to store data on memory or on the local disk, both have their advantages and disadvantages of performance and redundancy. We have also our retention, so we can configure retention based on size, based on amount of messages, or based on just amount of days that the messages will get cycled and dropped after a certain point of time. We also have the code examples. We asked initially, when we started to research and understand like what would be the next generation of or the developer experience, the next generation developer experience around message brokers, we constantly heard the phrases like, it takes time to onboard developers to the system, it takes time to educate developers how to work with the streaming platform itself. So as you can see, it's all written here. You don't need to go to the documentation. You can simply choose your type of protocol, if it's REST or if it's a client-based SDK, choose your language, and then just create a producer or consumer with all the needed metadata to connect into Memphis. So basically, if you chose Go, you would install the package and then create a producer and just run, and then just run it. So that would be the first part. Second part, very, very interesting one that is helping a lot of our users is the entire world of schemaverse. So for example, the alternatives to schemaverse would probably be Confluent Schema Registry or AWS Glue. So Memphis come up with Schemaverse. So Schemaverse is all about enforcing standardization or enforcing schemas over ingested data. So if you have only one producer and one consumer, you would probably not feel that challenge a lot. But as you grow and as you scale and more data sources comes into the play and pulls data into the same station, then things get a bit tricky because each producer that was made by different team produced data in different formats or in different shapes, and the consumers on the other side just simply not aware to that. So if you want to avoid that situation, you can simply create a schema, choose the format that you would like to enforce on top of the designated station. So for example, if I'm choosing JSON schema, then I'm making sure by putting a schema or enforcing a schema on a station that if the ingested event by the producers will not be complied into or by that structure, it would simply be dropped and not get ingested into the station itself. We're really helping to create standardization over branched organization and also to increase data quality. Yeah, so I think that is it in terms of the walkthrough. Super easy to use. And last but
Yeah, I
not
was going
least,
to ask about the functions. Oh,
exactly.
it says coming soon. Okay.
Yeah, exactly. So I just, in terms of confidentiality, I cannot
Sure,
reveal it
sure.
yet,
Yeah, no.
but it's
I
going
just
to
saw that
be.
it's coming soon.
No, it's perfect.
Um,
Yeah, thank you. I'll just say a quick word about it. It's going to be uh, revolutionizing, a game changer in the world of serverless and event streaming and processing, and also will enable Kafka users to work with Memphis. So I would love to do a follow-up once it's go out, and it's going to be in collaboration with the biggest or the major clouds, and a very interesting feature or capability for developers.
yeah, sounds really cool. You definitely should come back to talk about that. Um, Last thing I want to ask about the integration section, which are the most commonly used integrations.
So it's not filled out yet. It's going to be in the coming release. It's going to be filled with at least 10 more integrations. Currently, the Slack notifications and the Grafana for external monitoring, which is available on the open source only and not in the cloud right now. Those would be the two most popular integrations that are being used by our users. But we also, interestingly, we just released to the open source not an integration with Discord, and we also see a big traction and big usage around pushing notifications towards Discord. So perhaps it means something about the new selection of new projects.
Mhm. Yeah, Discord is quite popular. I saw on your website, by the way, great looking product here. Thanks for the walkthrough. What I
Thank
love
you.
about is the product looks really modern and makes you, makes you feel good using it, looking at it. A lot of times the website looks great, but then you go to the product, it looks really like from 10 years, 20 years ago. But I think Memphis looks as good as its website. That's saying something.
Thank you.
I want to ask about this thing I saw on your website, which talks about minutes to production. And that's definitely something that a lot of software teams strive for. Faster deployments, minutes to production is kind of like the goal. How does Memphis enable faster deployments?
So that's super interesting. I mean, minutes to production actually came from literally from our users. So based on the 4,000 developers that are working with Memphis, the average time to reach value, or the average time that it takes from deployment to actually ingesting data into Memphis is literally 5 minutes. So it's minutes to production in terms of the deployment is super easy. You have zero management, you have zero maintenance, or as I always say, close to zero, because there are no zero maintenance or operations, but definitely not a very heavy one. So it takes really minutes to reach your environment or to implement Memphis, and then to connect your code or connect your application into it and start produce and consume data from it. That also takes minutes. So if you combine both of them, you get a very, very fast time to success.
Mhm. Wow, that's cool. I also want to ask about Memphis Cloud. I think that's something more recent. If you can tell us about Memphis Cloud, what it is, why you launched it, that'd be great to hear.
Yeah, of course. So we've been asked by multiple customers, multiple users, to have a managed, a fully supported, hosted version of Memphis. So it really made sense to create Memphis Cloud, and that is also our main monetization driver. So basically, the company main revenue is derived from Memphis Dev Cloud subscriptions and usage. So that would be the main drivers behind Memphis Dev Cloud, and it also enabled us to provide support or to enable Memphis to support the larger enterprises that requires a fully managed SLA-based compliant platform of Memphis, and just don't want anything concerned of building the infrastructure on their own, which is perfectly standard, I would say, these days.
So what we saw just now, is that Memphis Cloud or is
It's the Memphis Cloud, yes.
Okay, so it's the SaaS version of the open source Memphis.
It's the SaaS version, but we do our best to keep the alignment between the open source and the cloud. And we work twice hard. I mean, it's not easy to maintain both versions, and definitely not to provide the same experience, or sorry, to provide the same experience between the cloud and the open source. So we're working hard, but it was really important for us because I always described our company as an open source company, as an open source first company and product. So we don't want to jeopardize the love of our community and to our brand. So we really do our best to keep both of them aligned.
Got it, got it. What about security? Are there security concerns that people who are managing message brokers should be aware of? And does Memphis address some of those concerns?
I would say the major ones will be multi-tenancy, role-based access, and probably compliance in terms of how the company itself is managing its internal processes. So if I'll start from the start, or from the most important, which is, for example, multi-tenancy. Multi-tenancy is all about separating concerns or separating customers from one another to make sure that data of one customer is never get exposed to other customers. We are doing, or we highly investing in that area, constantly do tests, external penetration tests, and also within the company, we have a dedicated team that is solely focusing on that. And also we offer multi-tenancy for our customers. So it's really to enable them to create the same separation within their internal assets and components and between their customers. That's the first thing. The second thing is the authorization, which is role-based access in compared to ACLs, for example. I, as a developer, don't really love the idea of ACLs. I find it highly hard or challenging to work with. One time I was in a conference, in a Kafka conference, and the speaker asked the audience, how many of you are using the same username and password or the same user for all of your client for all of your Kafka clients, and basically the entire room raised their hands. So that means that they are not lazy and don't want to create more clients. It's just simply hard to perform or to implement it using ACL. So we chose role-based access that really enables to create separations onto the station level all the way to the tenant level. So basically you can create clients that only does reading for specific data in specific stations. And last but not least, compliance. So we are SOC 2 Type 1, Type 2 compliant, also ISO, GDPR, data privacy, something that we do all the measurements that is needed, both from the regulatory side and both from just being concerned or and taking it in the right measurements. So our organizations and customers that are using Memphis would be able to trust us with their most valuable asset, right, which is their data. So those, I would say, the three main pillars for security in Memphis.
All right, that's cool. As we wind down, I want to ask, how do people get started with Memphis? Do you suggest getting the open source Memphis, or do you have a trial? What's the best way to get started?
So I think both. Memphis offers a free tier and soon to be trial mode. So I think that entering the cloud and really exploring Memphis experience is really, really easy, and no credit card is required. So if you prefer not to run it yourself, then you can just simply sign up to the cloud. The second way to enter Memphis or to start work with Memphis definitely would be the open source project itself, which is super aligned with the cloud and also really easy to implement. So you can install it on your laptop using Docker Engine if you have one installed on your laptop or your computer, or just simply install the production the production type of Memphis on any Kubernetes on any cloud. It can be Minikube, but it can also be GKE or AWS Kubernetes or Azure Kubernetes, whatever Kubernetes that you prefer, and you would have an instant Memphis cluster, fully available and production ready in one command.
Yeah. Last question for you on the topic of message brokers and Memphis. Just as you look ahead, right, the next few months, the next couple of years, 1 to 2 years, what excites you most about this space? What are you most looking forward to? Any development, any trend that you see on the horizon?
I think that data in general is something that I'm very passionate about. So not just specifically message brokers, but data in general. We can see what data can bring to the world with the latest trends and events and ChatGPT and LLMs and generative AI and all of those stuff. Basically, they derive from data at the end of the day. So data itself is really a fascinating domain, which I think that most of the current questions that we have would probably be answered by data that we already collected. So it's interesting to see what more we can achieve with the data that we already have. So that's the first thing. The second thing, or maybe more focused on message broker, is that we just started to see the potential of message brokers, definitely in compared to databases, in compared to traditional storage systems. So I think that domain is very, very interesting. It would be more utilized by developers, and I think that the vendor that will lower the entry barrier and bring more developers and new crowds into the play would win the competition and win the developers' heart. So would be interesting to see how it gets evolved.
Yeah,
I'm
really
so
cool.
sorry, Twine. I need to jump on another meeting in 2 minutes from now. But first of all, I want to say that it was a very, very good discussion. and I really enjoyed it, and that was like awesome questions, and I'd love to stay in touch.
Sure, sure. Thank you so much, Yaniv. We'll skip the get to know you questions. Keep it for the next time we meet. But thank you so much
Unfortunately,
for all you shared. It was a wonderful conversation. We hope to
thank
have
you
you
very
back.
much.
All the best with Memphis.
Thank you, I appreciate it. We'll stay in touch. Thank you.
All right. Thank you. Bye bye.